Welcome back to section 4.5, graphing sine and cosine. Today we're going to look at this third bullet point, sketch translations of the graph of sine and cosine. So we can shift the graph up or down, or maybe left and right. Let's see what we've done. Oh, well, first, couple of prerequisite skills. If I got a 1 and I'm going to add 1/3 to it, I could write that as 1 and 1/3. And then as a mixed number, or excuse me, improper fraction, 3 times 1 is 3, plus 1 more is 4, so that's 4/3. How do you cut a fraction in half? If the numerator is even, you can just cut the numerator in half and leave the denominator alone. If the numerator is an odd number, you can just double the denominator. And that'll work here too. If I double that denominator, it would be 4/6. What does 4/6 reduce down to? 2/3. So to cut a fraction in half, cut the numerator in half, or if the numerator is odd, just double the denominator. Let's do this one. 2 plus 1/3 is 2 and 1/3. That is the same thing as 7/3. The numerator's odd, so I don't want 3.5 over 3. Decimals within fractions is bad math manners. So let's double that denominator. 7/6 is that number cut in half. Now, if we were going to shift, think back to when we were doing our simple polynomial equations. Here's x squared. What about x plus 1 quantity squared? The plus 1 in there with the x means we're going to move it to the left 1 unit. Since it's a minus in this one in blue, that would move us to the right 1 unit. And then just for the sake of argument, if I did x squared minus 1, now the x is squared before we subtract, that would be a shift down. So if it was a plus 1, shift up, minus 1, a shift down. We're going to be doing something similar with our sines and cosine graphs. So the book says the constant c in these general equations, we've got y equals a times sine of bx, and then a minus c or a plus c. You know, it's in the parenthesis with the x. So you're going to see something like this, y equals sine of x. If I did minus half pi, it's in the parenthesis with the x, so that's a left or right shift. And since this is a minus, it's a shift to the right. So I would pick up my graph here, or you could do each of the 5 graphing points, and you're going to bump it over to the right half pi units. So notice this point got shifted over. This peak got shifted over, this x-intercept got shifted over, this valley got shifted over, as did the ending point got shifted over. All 5 of those dots got shifted to the right half pi. So it says here, this implies that the period of y equals a sine bx minus c is 2 pi divided by that number in front of x, and the graph of y equals a sine bx is shifted by the amount of c divided by b. That is the phase shift of the graph. So the graph of a sine bx minus c, and the same for cos, have the following characteristics. The amplitude, the absolute value of the number in front of the trig function. Period, 2 pi divided by the number in front of x. And now the new stuff is here at the bottom. The left and right endpoints of one cycle of the interval can be determined by solving these equations. Now, like, remember, sine started at the origin at 0, and it ended at 2 pi. Those are the old beginning points. To find the new beginning points, you set here what's in the parenthesis, bx minus c. You set that equal to 0, and you get your new start point. And you can also do bx minus c equal to 2 pi to get your ending point. Now, another way to do this, and you'll see me do this in the video, is when you find the start point, here we're starting at 0, and if you know the period, the start point plus the period will take you to the ending point. So you don't have to solve both of these equations for the new beginning and the new end. Just find your new beginning point and add the period to get to your ending point. And remember, those will be the first 2 dots of the 5, and then you're going to do 3 more inside. Excuse me. Okay, I'm going to make a little change to this example 4. I'm not a big fan of this third pi, so let's change that in your notes. Y equals 1/2 sine quantity x minus pi over 2. Half pi is going to be a little bit nicer to work with. Okay, let's do the good stuff we saw in the last video. Amplitude is 1/2, so we're going to have a high point of positive 1/2, low point negative 1/2. Period. The period is 2 pi divided by the number in front of x, and in front of this x there is an implied 1. So the period is 2 pi. So our cycle is going to be 2 pi in length, but we do have a shift, minus pi over 2. So remember, my first sine dot should be here at 0. But if I set x minus pi over 2 equal to 0, I would add pi over 2 to each side. Our new starting point is going to be at half pi. And I'm going to put that right about here, half pi. So we're not going to start at the origin. That's been bumped over. Now I'm going to put, let's see, keeping this scaling size, this will be pi, 3/4, 2 pi, oops, so pi, yeah, that's 3/2 pi, 2, and then this will be 2.5. So remember now, this first dot at the origin got bumped over to half pi. If I'm at 1/2 pi and I add the period 2 pi, that's going to take us all the way to 2.5 pi. That's our beginning and our ending point. Right in the middle between 1/2 and 2.5 is going to be 3/2, or we could think that the dot that was at pi got bumped over half pi to this new location. And then let's figure out our peaks and our valleys. We're dealing with positive sine. So from the beginning point, we're going to go up to a peak. That peak used to be at a half pi, but it's also been bumped over. So now we've got our peak at pi. We cross at 3/2. We used to have a valley at 3/2, but that got bumped over to 2 pi, where it's going to be now located. So there's our new shifted graph. And if I would have done this all in one spot, we could see it like this. You know, it used to be the sine wave would look like this. Start at the origin, cross at pi, end at 2 pi. But the minus pi over 2 bumped each of those 5 dots half pi to the right. So now our graph looks like that. Okay, so if it's inside the parenthesis, if we have something going on in there with the x, with a plus or minus, that is a shift left or right. Ooh, now this one's got some interesting stuff going on in it. Looks pretty complicated. -3 cos 2 pi x. That's weird to have a pi in there with the x. And then here is our left or right shift. So let's start with the easy stuff. Amplitude is 3. So we're going to go from 3 to -3 on the y-axis. Let's find the period. The period is 2 pi divided by the number in front of x. So here's our x. What's touching x? 2 pi. Look at that. 2 pi divided by itself is 1. Now, because the pi's canceled, when we scale our x-axis here, or our angle axis, it's going to have no pi's on it, just whole numbers. And now let's find our new starting point. Let me put a dot where the old one would be. Negative cos would have had our starting dot down here in a valley at -3 on the y-axis. But that's going to be shifted. Let's set what is equal or inside our parenthesis, 2 pi x plus 4 pi. We're going to set that equal to 0 because that's where we usually begin our cos graph here. And now let's solve it. Let's subtract. Oops, I should have put my pi first, but you get the idea. Subtract 4 pi. And now we're going to divide both sides by 2 pi. X equals -4 pi divided by 2 pi. So the pi's cancel. -4 divided by 2 is -2. So here on our x-axis, this would be -1. And this here will be -2. So where we usually begin, down here in the valley at -3 right on the y-axis, that's been moved to the left here to -2. Okay, we're ready to get the party started. We know that the period is 1. So if I'm here in a valley at -2, 1 unit later I'm in my ending valley, and this will be one cycle of the graph. At -3/2, we're going to have a peak up here at 3, and that means we're going to cross at -1 1/4 and -1 3/4, and our graph would look like this. Let's do another cycle. Period is still 1, so if we're from -1, we'll do another cycle by the time we get to the y-axis. So there's our beginning and ending valleys. Here at -1/2, we will have a peak, and we'll cross at -3/4 and -1/4. So here's another cycle of the graph, and I'm just having too much fun. Let's do one more. Period is still 1, so we're going to go from 0 to 1. We're starting in this valley at -3. We will end in another valley at -3. We will have a peak at 1/2, and our x-intercepts at 1 3/4. And there's another cycle. Okay, I think you get the idea. So big idea here is we had our pi's canceled, and our x-axis or angle axis now no longer has pi's in it. But we're still using those same 5 dots to come up with our graph. The final type of transformation is a vertical translation, up or down, caused by the constant d. Now, even in the book, here they put it at the front d plus, and then we have our trig function. They could put it at the end plus d as long as it's outside the parenthesis. And the book does do it in before and after the trig function. That's led to confusion in years past. So that vertical shift can appear anywhere, at the beginning or the end. Just like with polynomials, if that d value is positive, it's a shift up. If it's negative, it's a shift down. Okay, and I'm going to introduce a word here not in the book, but I like to call this, this shift is moving our baseline of the graph. Up until now, our baseline has been the x-axis. So that is always what we've gone above and below when we find our amplitude. Our function is snaked or wrapped around the x-axis, or I'm going to start calling that the baseline. In this case, the baseline has been shifted up. So here we've got a 2, a positive 2. So I'm going to do it like this. I should have made this axis a little bit longer. So I'm going to take this up to maybe 5. And I'm going to eyeball this. This would be 2.5. So there's 3 and 4 and 1 and 2. So we've been shifted up 2 units. Now the book doesn't tell you to do this, but I encourage it. I'm going to put a dotted line at where my new baseline is. So here is, so to speak, my new x-axis. The function will wrap around this dotted line and not the x-axis anymore. Now from the baseline, we're going to apply the amplitude 3. So from the baseline, we can go up or down 3. If I'm here at 2 and I go up 3, that'll take me to 5. I'm going to put a blue dotted line up here. This is sort of my ceiling. We will never go above this ceiling. I'm back at the baseline of 2, and now I'm going to apply the amplitude down. I'm going to go from 2 down 3, down to -1. So here is the lowest my valleys will ever go. So we're stuck. We're going to bounce back and forth in between the blue dotted lines, and we will no longer have x-intercepts. We will cross the baseline at certain points. Okay, what's next? The period. Period is 2 pi divided by the number in front of x, which is a 2. So those 2's divide out, and we get pi. Now I'm going to do, it looks like one cycle to the right, so I'm going to go out here to 1 pi. So this will be a 1/2 pi. And then we've got 1/4 and 3/4. And let's do a cycle to the left. So over here to -pi, -1/2, and we've got our quarter marks. Okay. Usually positive cos would start at a peak, but remember we've shifted everything up. So the highest peak we're going to ever go to is right here at 5, right on the y-axis. So this positive cos begins on a peak. 1 pi later, the cycle's over and we're back at another peak. In between the peaks, 0 and pi, at half pi we're going to have a valley, and that valley is down here at -1. Now remember, we're not going to cross the x-axis between these peaks and valleys. Right here at quarter pi, we're going to cross this baseline, y equals 2. Same thing here at 3/4, cross that dotted red baseline. And if I draw in my cos wave, nice smooth flowing curves, there we go. Now let's do one to the left of the y-axis. Again, this positive cos begins and ends on a peak. Our period is pi. So if we're here at the y-axis, we'd jump to the left to -pi. Here's our beginning peak. Our ending peak will be right here at the top of the y-axis. In between the peaks at -half pi, we'll be down here at a valley at -1. In between the peaks and the valleys, cross that baseline. So here in red ink is another cycle of our cos wave. Okay, what's next? Practice problems. So here it just says describe the relationship, talk about the amplitude, the period, and any shifts. This last one here, ooh, now hold on. Sine of x minus a half pi. Did we do that one? Yeah, it was a half sine. So let's change that one to make that in your notes a plus. We'll shift that the other way. And then there's 2 cos x minus 3. That 3 is outside the parenthesis, so that is a shift down. Make sure to pay attention to your amplitude. So pause the video, try those practice problems, and then start it up and see if you got them right. I have faith in you. Okay, number 19. Let's look at the amplitude first. The amplitude for both equals 1. A equals 1, so that's the same for both. Period. The period is 2 pi divided by the number in front of x. So for both of those functions, the period is 2 pi. F of x is unshifted, hasn't been moved any direction, but g of x has been shifted. We would usually start at 0. If we set that equal to 0 and add pi, you'll get 1 pi. Or remember that minus tells us we're going to shift to the right pi units. So g of x is going to go right, that's supposed to be a g, right pi units. Okay, now this one, again, we're going to change that to a plus. Let's just do 1 period on this one here. Oops, that's not very good. And because this is a plus, we're going to be shifted to the left, so I'm going to draw a little bit to the negative y-axis here. And let's see, I'm going to call this, because that's a shift plus half pi, I'm going to make this minus a half pi this far. And then I'm going to eyeball that. This will be positive a half pi, positive 1 pi, positive 3 halves, positive 2 pi. Okay, I'm going to switch to red ink. Amplitude is 1, so we're going to go from 1 to -1. Period is 2 pi divided by the number in front of x, which is a 1. So we're going to have a full cycle in 2 pi radians. But we can either look at this as a shift to the left, pi over 2 rads, or you could set what's in the parenthesis, x plus pi over 2 equal to 0, subtract pi over 2 from each side, and we get negative pi over 2. That's where this graph is going to begin. If we're at negative a half pi and we add the period, we figured out the period's 2 pi, negative a half plus 2 takes us to positive 1.5. So this is where our cycle will end. In between the beginning and the end of the cycle on sine, we have an x-intercept. That'll be right in the middle here. And because it's positive sine, we'll start at negative a half pi and go to a peak. So once we've hit the peak and then we cross the x-axis, that means we're headed for a valley right below pi. And then that's going to hit the valley at pi and come back up and finish. So if I do the original, if our graph wasn't shifted, the dots would be here in blue. We'd start at the origin, we would end at 2 pi, we would cross in the middle, we would first go to a peak, and then after the cross again, we'd have a valley. So the plus pi over 2 shifted every point over half pi left. That jumped over, the peak jumped over, the x-intercept jumped, this valley moved, and as did our ending point. So there's 1 period of sine of x plus half pi. Now here's another one. Ooh, and I just noticed here in the directions it does say include 2 full periods, so I apologize. I don't want to make the video longer by going back and doing that. Here we go. New function. Again, that is a minus 3. It's not in there with the x, so that is a shift down 3 units. Our amplitude is 2. Amp equals 2. And the period is 2 pi divided by the number in front of x, so that's just 2 pi. So I'm going to do an xy axis, and we're not even going to need to go up into the first quadrant, so I'm going to do it like this. And I'm going to go out this far and call that 2 pi. Cut it in half, there's pi. Half again, so 1 halves, 2 halves, this will be 3 halves. Okay. And let's see, we're going to go down 3. 1, 2, 3. We're going to have to go down to 5 here. So this -5, -3, -1. So I'm going to do a red dotted line for my shifted, what I call baseline. We moved our x-axis down to -3, so I'm just going to do a little red dotted line there. This is our new x-axis, so to speak. From that baseline, we apply the amplitude. Amplitude is 2. So if I'm at -3 and I go up 2, that'll take me to -1. And if I'm at -3 and I go down 2, that takes me down to -5. So here's my sort of constraints. I'll never go outside of the blue dotted lines, and I will cross that baseline in the middle. So let's see. I guess I'll use black ink for the actual graph. And this is a positive cos wave, so it will start at a peak. The highest peak we have in this graph is here at -1. So that is going to be our beginning peak. Our period is ended at 2 pi, so we're going to have our ending peak at 2 pi. In between these peaks, right at pi, there has to be a valley. As low as we go is -5. And then in between the peak and the valley, at half pi, we will cross that baseline. Same thing at 3 halves pi as we're headed back up. And we connect the dots with a nice smooth flowing curve. And that's a pretty good cos wave. Outstanding. And I think that was our last one. Yeah. The assignment here, again, it's out of the book, page 304. These 4 problems. Make sure you read the directions. If it doesn't say to graph it, you don't have to graph it. If you're having fun, though, go right ahead and graph it. And if it does say do 2 periods, make sure you do those 2 periods, unlike me in that last huddle problem. All right, I will see you in class.